Hello! Today we are going to be taking a look at those two quite interesting items that I recently purchased for my solar installation. We are going to be starting from the tiny one, and that's because it is a really important item to have. And as you can see, it is a PV fuse. This is a photovoltaic fuse dedicated for DC voltage. As you can see, it is rated up to 1 kV, and it is quite interesting because on both sides you've got a MC4 connector, so you can basically retrofit it into any installation, any location. So for example, here I've got like a DC disconnect switch, and if I would like to add a fuse, I can just plug it like this, and here we can get a wire and we can basically connect it like this, and this is all the job that you have to do. You do not need to splice any wire, you just adding it like that, and in my personal opinion it's got a really nice streamlined look, so it is going to be quite interesting. Of course, that do not need to be like a disconnect switch like this, because this is a regular MC4. So anything that is using MC4, you can like splice a wire and put it in between. Yes, we've got a wrong color code because this is a totally different wire for different application. So you can disregard it, but let's take a look what kind of fuse we've got inside, because it's going to be really beefy because it is rated up to 1 kV and it is a lot. Regular like glass fuses are mostly rated up to 250 volts. So you can see this is a really beefy one. Just take a look. Let's try to undo the second side, and most likely we will be able to push it. Just take a look what kind of beefy fuse. We've got a nice O-ring. Yeah, this fuse reminds me very much fuses that were used on a Fluke multimeter. I'm not sure if this is like, just take a look what kind of high we've got a breaking voltage. We've got like a 10,000 amp. This is a crazy. This is what you would like to see, and indeed it is a 20 amp. And I can give you a dimension. Here we've got our measurement tool from the iFixit, and I'm wondering if it's still working, but looks like yes, they've got like a common fault. I'm not sure they are draining battery, like they are activating themselves. And here you've got the dimension for the fuse, just in case you would be interested. Yeah, this is a really beefy one. Let me grab a regular one for compare. Here is a regular basic glass fuse, and of course the difference is the breaking current. In case of very high current discharge, this will evaporize and it can create arc and still pass current. Most likely there is going to be like a sand that will try to break the like a arc. So yeah, this is a beefy one, this is a good one. I enjoy it. So let's try to put it back. We are inserting it here and we've got a good fit. This is a good connection. Then we screw that element just like that. And this part needs to nicely fit in. And we have to screw it and make a good seal. In my personal opinion, absolutely beautiful, and it wasn't really that expensive. Most likely this is a really common item. Beautiful. And this is a photovoltaic DC switch. I'm pretty sure that when you think of a disconnect switch, you most likely think about using a regular AC switch that is commonly used, and absolutely you cannot do it. And that's because the AC switches are not designed to break DC arc, and the contacts are going to be melting, or you can even have an arc that is not going to be extinguished. And that's because on the AC voltage, you've got a point where the voltage is crossing 0, and this helps to extinguish any arc. But on DC, we've got a constant current flow, and you do not have that opportunity. So the physics is not giving you any advantage. If you don't believe me, you can check documentation for like a toggle switch, and most likely you are going to be finding information that the breaking load current for 250 volt AC is going to be indeed, for example, 10 amp, but for DC at much lower voltage is going to be only, for example, like 2 amp. So that's why you've got the difference. And here you can use like a high voltage, multiple strings, so you definitely need to have a dedicated item. Sometimes on 12 volt you can get away, but on higher voltage you will get a really horrible arc. Here you've got the model number and more technical details. What is quite interesting is the table that is basically confirming what I told you. And here you've got like a breaking current, and for example you can get 40 amp at 600 volt string, but if you are using 800 volts, then the breaking current is going to be only 25 amp, 1000 volt only 16 amp, and with 1200 volts you just drop to 10 amp. So this is quite interesting. This is exactly what I told you. You need to have a bigger spacing and elements for like basically trying to extinguish the arc. That switch is designed to be supporting the tag out lockout procedure. So when we go to the off position, you can slide that red element and you've got a hole, and into that hole you put a small padlock just like that with a tag that is going to be telling you that someone is disconnect the power and no one should enable it. So you've got it locked, you've got the key, you've got it tag out, and no one is going to be like basically turning it on until the padlock is being removed. So this is absolutely beautiful, and this is exactly what you would like to see, because this is quite like obvious if someone disconnect power, but if you've got like a circuit breaker that turn off, someone just might think that it by accident it was tripped and just energize it. So yeah, very important procedure. Let's try to open it and take a look what we've got inside. There is a quite interesting safety feature. When you've got it energized, you cannot lift the panel, so it has to be off. So you can basically remove it. And this is how it's presenting. We've got it made out of plastic, so it's not going to be passing electricity. It is very nicely wired. I really enjoy it. Just like with capacitors, you can wire two capacitors in series to increase the voltage. Here they done exactly the same, and just imagine that here we've got our incoming voltage. We go through one section of our switch, then the wire routed back to the second section, and we are using two separated switches in line. So this is absolutely beautiful design. Even if one of those switches would fail, then we've got also the second one, so I love it. And we've got that exactly the same thing going on second terminal, so I really enjoy it. Here you can see that we've got like a bypass play, so most likely it was used on like a AC, so that box is going to be very generic, because that's going to be on, I assume on the AC, that's going to be like a neutral or the earth that you are not going to be breaking. If your switch itself ever break, looks like they are using DIN rail, because I can see the pretty standardized element for unclipping it. And yes, you've got absolutely no problem swapping it out. We've got a DIN rail. So yeah, this is a really nice design. So it is presenting really nice. Let's try to put it back. And I really enjoy that screwdriver because it's got like a force control. So for electrical work, I press this button and it stops and basically never crack any plastic that I've got. So yeah, just take a look how nice it is. And you are done. And if we would like to have it in a real system, then we can quickly go like this. We could add our fuse, our wires, and you end up with something like this. So thank you very much for watching. I hope you find it interesting. See you next time and bye bye.